And welcome, my wonderful AP students, to an important and informative session today. We're going to talk about vectors, the trig involved, and X and Y direction. Hope you have colors handy. Hope you have some space in your notebook. You're doing a lot of stuff with me. Remember, write down questions you need to have answered in class from this. So here's the key idea. In physics, a lot of important things are considered to be vectors. Now, what is a vector? It has to have two things, a magnitude and direction. Remember, magnitude means amount, and direction just means usually a positive and negative, but not always. And today's where not always becomes the rule rather than the exception. So far we have three things: displacement, velocity, and acceleration. All three of these things are considered to be vector quantities because they all require magnitude and directions. Future examples include forces, fields, and momentum. Scalars are things that only need magnitude, so they don't care about direction. A major important one in physics is energy. You can have a negative energy, you can have a backwards energy. So energy does not require direction. So with direction, it depends on the frame of reference. In other words, it depends on how you're looking at it. And that's kind of a big thing for us. We saw in some graph problems how sometimes gravity is positive, sometimes gravity is negative. You have to look at the information given there. And this is no exception. As an example, here's a cute little backstaff. Now, in this picture, if I asked you at what angle is this line at, there are two possible ones. You could see them right here. The green and orange angles measured. The orange is the one measured from the horizontal. We're going to call that the X direction very soon. The green is in the vertical direction. We're going to call that Y. Both angles are complementary, of course, in this case, and both angles are technically correct. You could say that the orange angle is 60 from the horizontal and the green angle is 30. But you got to specify which one it is. Otherwise, if you tell someone the angle is 30, do they mean the vertical or do they mean the horizontal? So here's what I want you to think about it. Think about it like occurring on a plane. Here's a Cartesian coordinate system. Notice in this plane, x is positive to the right, y is positive up, x is negative left, y is negative down. These are usually considered to be safe assumptions, but not always. Again, sometimes there's a context in the problem to help you out. So here's an example of something. You have a red vector with two possible angles. My beautiful MS Paint skills are at work right now. Now, this could be a certain distance you run. It could also represent your velocity as an amount with an angle, or it could represent your acceleration. Notice that this is not like a time axis. So this could represent like a moment's velocity. And the length, which is red, is the magnitude. So the longer the red part, the more there is. More displacement, more velocity, more acceleration. And the direction part of the vector is considered to be the angle, brown or blue. So if this red part was, let's say, 20 long, and it was a velocity, you would say this is a 20 meter per second starting velocity, and at some angle. So let's get some terms. X right now is considered to be the horizontal parts of the motion, with plus and negative defined. So forward could be a positive x. Y is the vertical parts, with positive and negative defined. So when we use x is position forward. For position up and down, we should be now using y. So y naught is your starting height position, y final is your ending height position. The overall magnitude, or the overall result, is the length of that vector, that red we saw earlier. And there's also x and y parts of it we'll see. And then here's the thing. If your vector, whether it's displacement, velocity, or acceleration, is not entirely in the x or y, so it's not entirely forward or not entirely up or down, we have to use angles. We can't use positive and negative because it might be positive in the x but negative in the y. So instead we're going to talk about angles and let the person discover that from it. So here's a scenario for you. You do two different walks. You walk 14 meters at 40 degrees from east, then you walk 18 meters at negative 25 degrees from north. If you want to find your end position, you need to do some actual work with me on this. I'm going to show you how to set this up. So you walk a certain distance and another certain distance. We don't care about the time, so you want to figure out your ending point. Step one, make a good picture to help you out. And here's my picture. You're also going to separate the two walks into two separate sets of vectors to make it a lot easier. So notice I start at the origin always, because we always say use the starting position as 0. The orange is my first walk at that angle. Notice how it's positive from the east. The second purple walk is my second walk. And again, it's left or negative from the north. But Jock, aren't you walking the orange and the purple? Yeah, but with vectors, it doesn't matter how you put them together. We split them up because it makes it a lot easier to analyze them. So we assume they start at 0. Now watch as I start labeling in the parts. So first thing I'm going to do with the orange, starting at the origin, it's like I'm going forward positive x until I reach the last point before I can go up. So that little green arrow right here is the x positive component of the orange. And then from that x, I then go positive y up to reach the tip of the orange. Starting at the origin, ending at the tip, and I'm enclosing the angle. This turns the magnitude into a right triangle, which is always your goal. X is positive here because it's going right. Y is positive here because it's going up. Next up for the purple. Starting at the origin again, I'm going to go up, not over, because I want this angle to be inside my right triangle I'm building. This is a positive y, because again, this is in the positive y direction, it's up. And then from this point, which way must I go? Nice. Left, which is negative x. So at this point, I now made 2 right triangles. The whole reason is because I can't just add these 2 positions together. I have to find their x and y parts because those can actually combine. So here it is, made a little bit bigger. I put the numbers in there again. 18 meters is my hypotenuse of the right triangle, aka the magnitude, with an angle. 14 meters and 40. We're going to find the x and y parts of each one of these. So these 2 vectors will be broken up into 4. Green, red, blue, and brown. And in doing so, we're going to have 2 x's and 2 y's. Step 1. This y let's do. This is opposite of the 40 degrees. Opposite in a right triangle, and then you know the hypotenuse is going to be sine. So sine of 40 is positive y over 14. Opposite over hypotenuse. Solving for y, I get positive 14 sine 40. In degree, not radian. Let's do green. Green in this case is the adjacent to the angle. That means cosine. So positive x adjacent over hypotenuse, x over 14, equals cosine 40. Solve for x. X in this case is 14 cosine 40. So now we know the x and y components of the overall magnitude. Let's do the other one now. This blue, well, it's adjacent to the angle, so this blue is going to be cosine. Y over 18, adjacent over hypotenuse, equals the cosine of the angle. Solve for y, 18 cosine 25. And then for the x, it's opposite the angle, so it's sine. Negative x over 18, negative because it's to the left, equals sine of 25. Which means x is negative 18 sine 25. Once we have all these are the 4 components to our situation. We're not to solve for them quite yet, but we're going to take them and organize them into a new kind of table that will really help us experience what's going on. So to summarize, we just use sine and cosine to find the x and y parts that we're going to call the components of 2 separate vectors. So we took 2 things at angles and found the forward or backward and the up or down parts of it. Each x and y component has a positive or negative value. Since we took away the angle, and since they're no longer at an angle, we could use positive and negative to express them. And they also have a magnitude. They have a certain length we can calculate. So they're still vectors because they have a direction, not represented by positive or negative, and they also have got that amount. At this point, we've made 2 right triangles, and we found them out. When you come back to class with me, we're going to use this fact to help explain why things happen in the air. And I cannot wait to tell you this on day 9 of your AP Physics class. Take care. Have a good day.